What is machine learning? Machine learning is a subset of artificial intelligence that involves the use of algorithms and statistical models to enable computer systems to improve their performance on a specific task as they are exposed to more data. In other words, machine learning allows computers to learn from experience and automatically improve their performance without being explicitly programmed. Here's a more detailed explanation of the key concepts involved in machine learning. Data collection. Machine learning algorithms require data to learn patterns and make predictions or decisions. This data can include various types of information, such as text, images, sound, numerical values, and more. Data preprocessing. Raw data often needs to be cleaned, transformed, and organized before it can be used for machine learning. Preprocessing steps might include removing duplicates, handling missing values, converting categorical data into numerical formats, and scaling features to a similar range. Feature selection. In machine learning, features are the variables used to make predictions or decisions. Selecting relevant features is crucial, as irrelevant or redundant features can negatively impact the performance of the model. Feature selection techniques help identify the most important features of the task at hand. Choosing a model. There are various types of machine learning algorithms, each suited for different types of tasks. Common types include supervised learning. The algorithm is trained on labeled data, meaning the input data is paired with corresponding output labels. The algorithm learns to map the input data to the correct output during training. Unsupervised learning. The algorithm is given in labeled data and must find patterns or structures within the data on its own. Reinforcement learning. An agent learns to make decisions by interacting with an environment to achieve maximum cumulative reward. The agent learns from trial and error. Semi-supervised learning. A mix of labeled and unlabeled data is used for training. Deep learning. A subset of machine learning that involves neural networks with many layers, deep neural networks. Deep learning algorithms excel in tasks like image and speech recognition. Training the model. During the training phase, the selected model is fed with the prepared data. The model adjusts its internal parameters iteratively to minimize the difference between its predictions and the actual outcomes. This difference is called the loss function. Optimization algorithms like gradient descent are often used to minimize this loss function. Evaluation and validation. After training, the model needs to be evaluated on new, unseen data to ensure it generalizes well to different scenarios. Common metrics for evaluation include accuracy, precision, recall, F1 score, and others, depending on the nature of the problem, classification, regression, etc. Hyperparameter tuning. Models often have hyperparameters that are not learned from the data but need to be set before training. Grid search, random search, or more advanced techniques like Bayesian optimization are used to find the best combination of hyperparameters for optimal model performance. Deployment and monitoring. Once a model is trained and validated, it can be deployed to make predictions on new, real-world data. Continuous monitoring is essential to ensure the model's performance remains satisfactory over time. If the model's performance deteriorates, retraining with updated data might be necessary. Machine learning finds applications in various fields, including natural language processing, computer vision, recommendation systems, fraud detection, autonomous vehicles, and many others, making it a fundamental technology in the modern world.